All right, good morning. Yesterday you started taking notes in section 4.1, probability distributions. I have it up right here. And I think the first couple topics, what a random variable is, what a discrete random variable is versus continuous. Discrete being things that are counted, continuous being things that are measured. The number line is a great way to illustrate this. If you have individual dots on a number line, that is something that is going to be a discrete random variable. Whereas if you have a range of values, meaning any decimal or fractional value between 0 and 24 on this example here is a possible outcome, that would be considered continuous. There are infinite number of possible values in between those numbers. From there, what I really wanted to talk about is what is a probability distribution, example number 2, and how do we construct one. And so I've created a spreadsheet using Google Sheets to show you some of the steps that they showed you in the next couple examples. I'll share this with you in just a moment. And my Google phone, every time you say something involving Google, it decides it's going to listen in. Terrifying. A probability distribution lists all the possible outcomes of an experiment and their associated probabilities of occurrence. Very similar to what we did back in Chapter 2 when we found the relative frequency column of a frequency distribution. Remember, we would take the frequency and divide it by how many total data points we had, and that gave us a decimal value. We called it relative frequency then, but I'm sure that I told you that it was similar to finding a percentage or a probability. All of the probabilities in your distribution must be between 0 and 1. That makes sense. We know that all probabilities have to be between 0 and 1. And the sum of the probabilities has to add up to 1 total. Okay? I did put a note here. Keep in mind, you guys are calculating one, you're writing it down, you're getting big decimal values, you're rounding them off to 3 decimal places. You get to the end, you add it up, it comes out to 0.998 or 0.999 or 1.002 or something like that. Chances are that's a rounding issue, and you probably still are correct, and it still is. So please use good judgment. You know that you're rounding things, and things might not work out exactly the way you hope they would. So I've already filled this all in here, but we'll go through the steps on how I did that really quick. This is the Try It Yourself 2 problem, which you were assigned to complete yesterday. They give you this distribution on the left, frequency distribution. It tracks the number of sales that new employees make each day during a 100-day probationary period. How many days did they have no sales? How many days did they have 7 sales, or anything in between? So they give you the list of all the possible number of sales. Apparently this new employee, or their new employees total, never went over 7 sales a day, and that only occurred twice. There were a lot more days with no sales at all than there were with 7 sales. It tells you that there were 16 days where employees made no sales. There were 19 days where they only made 1, 15 days where they made 2 sales. So make sure you understand the context of the chart that you're given. Our instructions here are to make a probability distribution with this. So this is what you would need to accomplish. All right. First thing I did was I created a list in Google Sheets of my X values, which was sales per day, and my frequencies, which was given to us in the list. Okay, 0, 19, 15, 21, 9, 10, 8, 2. I found the sum of those. I want to know how many data points I have total. I've got 100 data points. Okay, that's important to find, 100 data points. To calculate the probability, we'll use the formula equals our frequency divided by the total of our frequencies. So the number that's in the frequency column divided by 100, and it will fill that in for you. And then we'll just drag and drop that all the way to the bottom, and we get them all. Okay, so we know that there's a 16% chance that employees will make 0 sales per day. There's a 9% chance they'll make 4 sales per day. And that's what that column tells us. They ask us to verify the probability distribution. One of the easy ways you can do that is just You created it, so it should be correct, but you should always find the sum of that column. If we found the sum of that column, it should come out to 1. This sum equals here is actually for the next column. We'll talk about that in a moment. But if you wanted to double check that, okay, equals sum, and then just highlight these, and it should come out to 1. And you can see it's going to be 1. So we're good there. Next example they ask us to do, after verifying, we start talking about finding mean, variance, and standard deviation. It's very similar to when we did things like weighted means in previous chapter. Find the mean of a probability distribution, and they give us a formula that says mean is equal to the sum of our x values times our probability values. And keep in mind, order of operations says we do multiplications before we do additions. So we have to multiply our x values times our probabilities first, and then we need to find the sum of that. We can do that. So I've created a column here, x times p of x. I'm going to go ahead and highlight these for a second and center them to make me feel better. There should be at the front desk, there should be a thing, a pass. Sorry, I am covering study hall at the moment. So I've created this column, and we just put in, I'll delete these and show you how I did it. Equals, our formula says our x values, sales per day, times our probability values. And of course, that first one is 0 because there's days when there were 0 sales. Drag that down, fills in the table. Our mean is the sum of that value, so we know we've got a mean of 2.6 for this problem. Not too bad so far, is it? I do want to check something because I didn't check it before. Let's try if we did this. Equals average weighted. And if we do average weighted, we would need to highlight probably these x values, comma, and these probability values. And we got 2.6. Mathematically speaking, the formula to do a weighted mean, keep in mind, probability is divided by 100. So there is a division step in there, which you would use when you did calculated a mean. It's just not noted here. So you can use the weighted mean formula to find the mean, highlight your x values and your probability values, and you'll get the correct answer. Found the mean of our probability distribution. Now we have to find the variance and the standard deviation. Again, use these formulas as step-by-step processes. First, we have to do subtraction, x minus the mean. Then we have to square that value. Then we have to multiply that value. And that will give us our variance after we find the sum. Our next step then to find standard deviation is to take the square root. So I'm going to assume that if you have this example given to you here, that you would have the ability to follow these steps and repeat them. So we will take a look here. You can see what I did. X minus the mean, again. I'm going to delete these. Equals x. Our x values are our sales minus our 2.6. And we'll drag and drop that. This column is to take that previous number and square it. So I typed in equals the previous number squared and drag and drop. Our next column would be to take the previous number and multiply it by the probability, which we have over here. So equals the squared number times the probability. Drag and drop. Find the sum of that value, That's our variance. Take the square root of that value equals SQRT of that 3.72. And that will give us our standard deviation. So there you go. Creating a probability distribution, calculating a mean, calculating a variance, calculating a standard deviation. Can be a little time consuming, but it can be done. Thank you very much. Good luck.